Hello everybody, welcome back to the Lake of the Ozarks Scout Reservation. Right now we are in the Sinquefield Invention Lab, which is next to the metalworking building, which we had for the previous videos. Today we're going to be working in this facility, and we're going to be working in our program building or wood shop. All three buildings are part of our greater Invention campus. We got a lot of fun stuff to play with in here. A lot of really cool utensils and tools to make some really awesome stuff. So let's get right into it. For this first part, we're going to use the Epilog laser to make something really cool, something from Lord of the Rings, one of my favorite movies, favorite authors, J.R.R. Tolkien. So let's hop right into it. I'm going to show you the software first on how we actually input into the laser. We'll get something going, and then we'll go over to the wood shop, and I'll show you guys how to design and do something on our Shopbot router mill. It's all pretty user-friendly software. Anybody really can do it. I'll give you some basic tutorials, and then if you come down to camp, you can learn how to do a lot cooler stuff. But anyway, let's get right into it. I'm going to flip this back around. So, like I said, J.R.R. Tolkien, one of my favorite authors, loved Lord of the Rings, Hobbit, all of it. And I found this picture that was a kind of a silhouette of the Fellowship of the Ring, and traced it, and then actually added the script beneath it. So what's cool about this laser, it does not only rastering, but it does vector cutting as well. And rastering is the back and forth engraving that does the fine detail and stuff, or when you're actually engraving something, whether it be acrylic, a piece of wood, whatever. And then it does vector cutting as well. And vector cutting is where it's just a constant pulse of the laser that can cut through your material so you can cut stuff out. So if you can see this, the stuff in black, that's going to be what's rastered. That's going to be what's actually engraved into the piece. And then this red is the vector lines. I have that set at hairline. And in this program, when you set something as hairline, when you input it into the laser, it tells the laser that that's a vector cut. And so it'll actually cut that out. It's pretty cool. I always set it in red when I'm designing it, simply because it just helps remind me that, okay, that's a vector cut, and everything that I want raster engraved will be in black. It's just a good little tool that I use, a little trick I use, that I recommend people who use this stuff at home do, because that way you know the difference between your vector cuts and your raster engravings. So I already have this all designed, because clearly you wouldn't want to watch me sit there and outline all these. So this is all designed. We're going to input it into the laser and start the raster engraving, and then we'll go over to the wood shop and we'll do the project over there and show you. I'll actually show you guys how to design something on that, because it's going to be a pretty quick, simple design. And then show you how to set up the machine and get it going. And then we'll come back over here and actually let you watch this get cut out. So this, like I said, these programs are, this is just Corel Draw that we use for our laser engraver. And the programs is actually fairly simple to use. It's pretty user friendly. Once you have this all designed, you basically just go into the print menu and you set everything else up. The big thing to remember is always click out of your drawing or whatever, so you can see these two numbers up here. See, it says 24 and 12. That's important because you have to make sure that when you go to your print setup, that it knows the proper width of the media that you're actually going to be printing on. So got this all set up. So I'm going to go File, and then go to Print. See, right now, it's set up to only do an 8x11, and so it can't find the rest of it. So when you go into the print preferences for this, this is where you can set everything up. Now I'm going to do actually two separate prints, one for the raster and one for the vector cutting. So right now I'm just doing raster, so I don't have to worry about any of this stuff down here. So I'm going to set it up. I like Stucky because it does a little bit better detail. Bottom up. Set the speed at about 77 and power 100. Now this right here, this is the part I was talking about. If you try and print and you don't reset these two numbers, your horizontal and your vertical, to what you have set for your piece, it's gonna mess up your engraving. So it's always really important to make sure that you have those set to the pieces that you're doing. So 24 inches by 12 inches. 2412, 2412, all good. Okay. Everything looks good. We have our speed proper, power proper. I like to go bottom up on these, and sucky. Okay, I think we're ready to go. So notice how that changed. So now it knows the whole piece that's in there, and it's going to be proper. We have everything hooked up. So we'll go to print. And over here, the little data light, there it goes, lights up, and that lets me know that the data is transferring. So, go over here to our laser. Now right now it's not focused. I have it already on and kind of set up and stuff, but we got to get this focused, and there's actually a really nice tool for that. It's this guy right here. Put that on there, and then you go over to this menu right here. See, it says focus, and by moving that up and down, it moves your base plate up and down. And you use that so you can get a perfect focal length. If you don't get your focal length right, as in the distance from your lens to your media, then either it's one, it's not going to cut properly, and two, it's going to be wider. It's just going to mess it up. You have to have your focal length really perfect, just to get the best engraving. So I'm going to move this up. Now this will be sucked down with suction, so I'm actually going to push this down so I get the right length. And you just want to go till that just touches. Take that away. Okay, now it's about to get really loud because I have to turn on the suction system and everything that vents out all the smoke. And actually, by putting these pieces of paper that I have around here, because this right here, this is our cutting piece. It's a grid pattern of metal. And so by closing all this up, there's little holes that are back down in here. It actually sucks everything down and holds everything in place. So it's really important to keep your pieces nice and steady. So get this up a little bit. All right. So there we go. So what I'm going to do now, it's about to get loud. I'll try and yell over the fan, but it might not work. We're just going to start this out, and once it engraves just a little bit, you guys can watch for a sec. We'll go ahead and go over to the wood shop and we can start our project over there. And then once we get that going, we'll come back over here and I can show you guys how this is going to vector cut this out to get the nice edges I want. So it's really cool. The laser only fires where it needs to be engraved as it passes back and forth and back and forth and back and forth. It's just such a wonderful machine. This is a pretty simple project I'm doing on here, but we can do everything from like engraving metal water bottles and stuff, because we actually have a piece that I can show you that rotates pieces, like so you can do cylinders and such. You can use this for cutting out pieces that you're going to actually build together. Really kind of the sky's the limit. You know, that's why this is the Invention Lab, is because it's about inventing. It's about, you know, using having the technology and using the machines that we have to be able to kind of design the stuff that comes up in our imaginations. that's going to be a little bit. We'll come back to it. You guys will see the finished raster engraving, and we'll get that vector done. A couple things I can show you. This is kind of our storeroom back here, where we keep a lot of our tools and all the cool equipment that we have. Computers. This is our solution printer. It prints up to, I think, 64 inches wide. We can do banners, stuff like that on it. We walk out here into the Invention lab. Shut this door. Some sewing machines. I know it's kind of hard to see. Then we have different carts for sewing and cutting. This is our electronics and soldering cart for doing electronics merit badge stuff. Hand tools. Our 3D printing area. One of them anyway. Yay, Invention Lab. That's our awesome touchscreen TV we use for merit badges. Thomas, our Invention Lab manager, he uses it all the time for doing our big merit badge classes on the off season, and we use it during the summer a lot too. And might as well walk out on the porch before we head over to the wood shop, give you guys the beautiful view from our porch here. It's actually a really beautiful day. Sorry, that's the sun. Probably can't see much. There you can see the metal building over there. All right. Go on over to the woodworking building or program building. Here's Osage campsite. Everything's greening up real nice. Found some morels. Trees are starting to bud. There's our climbing tower. Gaga ball pit over there. To give you kind of the tour of the three facilities, there's a metalworking building, Invention Lab, and program building and wood shop. It's a little chilly out, but I got these doors open to make sure I got plenty of Wi-Fi so you guys don't get cut out. Here's our program building, woodworking facility. Again, right as you walk in the door, safety equipment. DeWalt hand tools. Those are 2 benches for hand woodworking. Shaper, planer, sander. This is our saw stop table saw. Miter saw. Now, we actually, the head ranger, Steve, and I, we put these cool wheels on our workbenches so that we can actually move them around. So if we want to do a big project on there, we can. Or during the summer when we have lots of people in here working on smaller projects, we kind of separate all these into 4 smaller workbenches. More hand tools. You know, that's kind of what we're about here, is just getting all the equipment that we can so that kids have the facilities and the equipment they need to be able to come up with their cool ideas and bring them to life. Now here is our Shopbot. Oh, I love this machine so very much because we can make all of our own signs with this. We don't have to contract out signs anymore, and not just doing letters and stuff. We can put images and pictures on our signs. We can use this, as you saw in maybe in other videos. I did the rules for the metalworking shop on this. So, the sky's the limit with this thing. There's a famous maker, actually Jimmy DiRista, that used it. He made a canoe with his. So, I mean, it's just a really, really marvelous machine. So, what we're going to do now is I'm going to actually show you guys how to design something on here and put it into the machine and get it to print. Okay. Let me get this so you guys can actually see what I'm doing here. And so I can see what I'm doing too. That's important also. Okay. So what we're going to do today on this is we're actually going to do Invention Scouts logo. Now, I already had the picture for the Invention Scouts logo that was designed, and all I did was turn it into a JPEG. On this thing, you can actually just import JPEGs. You import them as a bitmap technically, but you import them as a JPEG, and you can work from there, and it's pretty quick to be able to create something really cool. So import bitmap. Got my Invention Scouts light bulb. And it'll pop up here in a sec. I'm sure it'll tell me not responding. It sometimes does, but it always responds eventually. So here, zoom in so you guys can see a little better. There we go. Boom. So I don't even need to make this the size to fit this yet. What I need to do is create vector lines with it. Now, unlike with the other piece where I had to trace it all around, because I actually designed that years ago before I knew how to use some of this equipment a little better. So this piece just selected, there's actually something, it's called Trace Bitmap, and it fits the vectors to the selected bitmap. Just click that. Now this right here, this stuff, this gets into more detail, how loose or tight it fits the corners. When you get into more designing more technical stuff, that becomes more important. Basically things with a lot of detail, you want to have a real tight fit so it gets all your detail, but this, I know it seems like it's really detailed, but for this program it's really not, so I'm going to keep those corners loose. That also keeps your vectors kind of rounded, makes it look a little nice. And then preview that, and boom, it turned that into vectors. Now these black lines, these are the vector lines. So now what I'll actually do is I'm going to get rid of that initial JPEG, and what it's going to do is it's going to just leave nothing but my vector lines. See that? Pretty simple. Now I can worry about, sorry, I got to close this down. Now I can actually worry about fitting this to the piece. I want to get it as big as possible on here. Yeah, that leaves a little bit of room on the edges. I'm cool with that. Just to be sure, make it just a touch smaller. There we go. Okay. I can move that over just a touch. All right, I'm pretty happy with that. It's not too close to the bottom. Now I already have my board attached to the Shopbot itself, and it's really, really important when you're working with stuff like this, because you have to attach the board with screws to make sure you know exactly where your screws are going to be. There's actually a program on here, this part right here says drilling toolpath. It allows you to create circles in areas where you know there's going to be no engraving going on. And before you even start or attach your piece completely, it'll do these little peck marks, and that shows you where you can safely put your screws. Because if one of these router bits hits a screw going at the speed it does, it'll not only potentially mess up the screw, it'll definitely mess up the router bit, but it could send a piece flying and it could be dangerous. So you always want to make sure to be safe with this and make sure you know exactly where your screws are going to go. Okay, so we have that sized. We have it kind of where we want to on the board. Now I know the board I was going to use already was 20.5 inches by 48 inches tall. And when I set up my piece to start, that's where I set my parameters at. So you go here, this will show you everything, thickness and stuff like that. So, okay, now it's time to actually set up the cut files. And again, it's pretty simple to do. First thing I'm going to do is I'm just going to select this entire piece again. It's going to select all those vectors and go over here to vcarve. This is the program in this program that I use the most. What it is, it basically takes all of the areas that are encapsulated and knows that it needs to engrave into those areas. So go to vcarve. Now my piece is 3/4 of an inch thick. So I want to have it engrave about 1/2 an inch thick. That leaves 1/4 of an inch below that. And by doing that, it leaves enough space, but also using these V-carve bits, it makes these really deep gouges that gives it a lot of depth. Just makes it look really, really cool. Now the other thing here, I don't know if you can really see that too well, but it says use flat area clearance tool. This piece doesn't need it, but I usually have that clicked. What that is so if you have a large area that needs to be removed, the V-carve bit that I'm going to be using, this is an older one, is like this. So that's a 60-degree bit. The tip actually broke off this one. This is an old one, so I have a new one on there. So this is what engraves the little detail and everything. But you have to use a straight bit to remove large areas. But because this piece is fairly small, it's still 20 inches wide, but because it's still fairly small, it doesn't have any large areas that need to be removed. It shouldn't need that in there. But in larger pieces, like the sign we just did for the front of camp, it will. And so it's a good idea just to have that selected. So just going to hit calculate. It does its computer thinking stuff. See, the carving tool never reached the flat bottom depth. That's just telling me that, hey, there's not going to be a separate cut file for that end mill. So just going to hit OK. And you can see on here, these are just kind of showing you, these are the cut paths that it's going to take. Now, to double check to make sure I like that, and close that out, you can see that's my cut file for the V-carve. We can go to this cool little thing, preview tool paths. Now I love it. This actually shows you the board you're using and everything. You can set the colors on this, whatever. If you're using an actual acrylic or something like that, you can move it around, look at it from angles for when you're doing more deep gouging, or even if you're doing like three-dimensional stuff, like a mountain scene or a face or something like that. But I can say preview all tool paths. And that's going to show me exactly what it's going to do. I'd say that looks pretty good. So yeah, we can go in there. Yep, that's gonna look nice. Turn a little bit. What's that gonna look like from the side? Oh, it's gonna look just as good from the side. Sweet. Okay, so now I don't want this just to be a board with this on it. I want this to be cut out. And so there's a different part of this program that you use. Now I've been selecting everything all at once, but you can actually select these vectors individually. I can say, if you can see that turn pink like that, you can select these vectors individually to do various things with the program. And as you get more experience with the program, get more experience with the machine, that's when you can start to learn how to make different cuts and things like that, and use selecting various vectors differently. But for this piece, the whole thing selected with the V-carve program was just fine. So to cut it out, though, I just select that vector that goes all the way around it, okay? And then use the profile toolpath. Now this, I want to make sure this is set at 0.75 inches because I need this to cut all the way through the board. So it's always, remember, one of the biggest problems people run into with these programs is they either don't set up their material properly, as in they don't know how thick it is, or they forget and they don't set their cut depths. Because as the guy from Shopbot who taught us how to use this told us, one of the greatest things about this machine is it does exactly what you tell it to. And one of the worst things about this machine is it will do exactly what you tell it to. If you tell this thing that your piece is, your cut depth is 5 inches, it's going to try and cut down 5 inches deep. So it's always really, really important to make sure that you know all your parameters and make sure that you're setting them properly. So the one thing we do have to do, because this is going to be cutting all the way through, we have to add tabs to it. Now what tabs are, is they're these little areas where the router bit goes up, across, and back down. It leaves just a tiny little sliver of wood so that the whole piece, once you get to your last, as it starts to, cut it out at the end, it doesn't shift or anything. The whole piece stays stationary the whole time. Then you kind of break that out and you can sand those little tabs off. So I need to make sure to add my tabs. Now I want to see where they are. I'm going to go ahead and use 4 tabs on that and say add them. And it shows you where these tabs are going to be. It really doesn't matter too much where they are. It can, but as long as they're evenly spaced or they're not really in like a very detailed area like a sharp corner or something like that, you're going to be fine. Because you can actually move these along the vector line. So I'm happy with those 4. They're going to be sanded off anyway. Close. Okay. Now the thing you need to check also is there's 3 settings right here that says machine vectors. Now what this tells you is where it's going to cut in relation to that vector line. So outside right means it's going to cut along the outside. Now it knows the bit is 0.25 inches, so it's a 1/4 inch thick end mill bit. So the edge of that bit is going to run along the edge of this. If you put it inside left, it's going to put that bit on the inside of that. And if you put it on it, well, it's going to run the middle of that bit right on your vector line. Because I want this to cut it out, I want to make sure that I keep outside right. So that cuts outside like that. Okay. I think everything's good. We got our tabs. We got our cut depth at 0.75 inches. That's proper. Got the proper tool. Now you can select these tools. There's a whole list of tools that we have available. Most of what we use in here is the 60-degree V-carve bit and the 0.25 inch, the 1/4 inch end mill bit. That's most of what we use. But as you get into doing other things, you might need something else. So there is a list to choose from. Because like I said, this machine does exactly what you tell it to. And so it's very important that you also have the proper tool selected. Okay, end mill bit, outside right. Got add tabs to tool path. Yes, let's calculate it. Okay. Hope it's calculated that. It just showed me the tool path and shows which way that's going to go around. Close that. Now just to check it, I'm going to go back here. I'm going to reset the preview. And then I want to make sure the whole thing is going to go well. Now I'm actually going to save this as 2 separate cut files. One for the V-carve bit and one for the end mill bit. Because I've found that sometimes with this program, if you try and have multiple tools, the problem you run into is sometimes it likes to mess up during your tool change, and then you kind of have to start over, and you end up having to make a separate cut file for that tool. So for me, I like to just save each one of these as a completely separate cut program. That way, if I need to, I can turn the machine off. I can set it overnight if I don't have time, and then I can come back to it. It's just a good idea to do. Now, these are what I was talking about with these tabs here. You can see there, it's just a little tiny bit. It'll go up, across, and then back down to its final cut level. And that holds the piece steady as you're cutting it out. Okay. That was pretty quick. I mean, that was even with me explaining it, still pretty fast for showing how to design something. So what we're going to do now, we're going to save these tool paths, and I'll show you guys how to get the machine set up, and then we will go ahead and get it started cutting. And by that time, we can go over and I can show you guys the vector cutting on the Lord of the Rings engraving that's going on. So first, I'm going to select my V-carve because that's the first one I'm going to do. I already have a V-carve bit locked in the router. So exit this. I'll go to Save Tool Path. It says, okay, V-carve. It's just saving that one. I'm going to save that tool path to file. Now I have this on here. I don't want to name that V-carve 2. I'm going to call that Invention Bulb V-carve. Now, another thing the guy who came from Shopbot to teach us about this was he always said, put the name of the bit when you're saving your cut file. That way you always know when you load that cut file that you have the right bit in. So I say Invention Lab V-carve bit. Now I could put, 60-degree V-carve bit, but it's the only V-carve bit we have. And when I save the other file, I'll save it probably as Invention Lab bulb end mill cutout. And that lets me know it's an end mill bit and it's cutting out the piece that I have. So any information you can give yourself, especially if you're doing a lot of different engravings, it's good to put as much information as possible in your name of your saved cut file. So okay, Invention Lab bulb V-carve bit. Save that. Okay, now I'm going to click out of that. See, it disappears from this menu. And there's my profile. And I'm going to say Save Toolpath to File. Now I'm going to go INV bulb end mill cutout. That lets me know what it is. It's the Invention Lab bulb, the bit, end mill, and what it's going to be doing. It's going to be cutting it out. You can see, should be on here. Yeah. Invention Lab bulb carve bit, that's already on there. So, all right. So that's all saved now. Now, something that I always do before I go ahead and do a carving is I go back through and I look at my settings, because it's so very crucial to get your settings right on this. Not only so you don't mess up your piece, but also so you don't actually accidentally damage the machine or hurt yourself. Because if you forget to set your depth or anything proper, it'll ram down through the table. It's just it's something that's good to check. So just by looking at this part right up here, it's maybe hard for you guys to see that. This gives me a little layout. I can see that my depth of material is 0.75 inches. I can see that it's zeroed at the top. Sometimes if you accidentally click that, when you zero it, it'll think that the zero is at the bottom of the material. So when you go to actually zero the Z-axis, it'll be too high. So you want to make sure that your zero is at the top of your material. See, 0.75 inches. Okay, I'm all good with that. Now I'm going to go back to my V-carve. I'm going to look in my settings for that. Okay, it's only going to go to 0.5 inches using the 60-degree V bit. Okay, I'm happy with that. It's not going to use the end mill on that. Okay. Then I'll go to my profile and I'll look at my profile settings. Okay, the profile cut, I know what to go all the way through. So it's at 0.75, got the end mill, outside right, and the tabs are good. And so it's always good with stuff like this. You really, really, really need to double check. Because if you don't double check, that's how mistakes happen. And like I said, and I can't reiterate enough, this machine does exactly what you tell it to. So make sure that you told it to do the right thing. Okay, so I got my tool paths saved. There they are. There's Invention Lab bulb, Invention Lab bulb V-carve bit. There's mill, end mill, and V-carve. Okay. So now it's time to set up the material on the machine. Like I said, I already have it situated down, but that's not all you have to do. You got to make sure to zero it. So we're going to exit out of this now. And we're going to actually go to the Shopbot command. Now what I'm going to do so that I can, right now, we can get off this so you guys can actually see the machine. Da-da-da. Okay. So here's our Shopbot. Right now, the router's way over there, and so I can't really zero it to the material that's right here until I move it. So there's actually a piece on here you do that. I'll move this over. Another piece of advice for those of you guys who use this at home, never ever change your bit over open concrete floor. You always want to change your bit over wood. A lot of these bits are hardened alloy steel, and especially the ones with fine tips. If you drop it out of the router over concrete when you're doing that, it's kind of easier to move it all the way to the end to change the bit, but you drop that bit, you could potentially break your bit, and they are not cheap. So always remember, change your bits over the wood. So what I'm going to do now, I'm going to get this handy dandy little tool. What this is the zeroing plate. This clip right here hooks to the router bit tool itself, and then this sits flat on your surface. Now the reason that's connected with the cord is as soon as the router bit touches this plate, it stops because it knows the thickness of this, and that tells it that that's how far underneath it the material is. So that tells it your z-axis, your up and down, 0. So I'm going to situate that right underneath it. I'll go back over here. Now something I will tell you guys, I'll show you. So you can see this. This is the manual moving right now. I can click this and move it right, left, forward, back, or up and down. Before you zero anything, you have to exit out of that. Otherwise it won't let you. So I normally know the shortcuts, but I'll actually show you. C2 here is 0 z-axis with z-plate. It says, does its thing. Okay, hit enter when above plate and ready to 0. Okay, so I'm actually going to set this down for a sec, because as soon as I hit that, hit enter, it's going to make a noise and it's going to start going down. And it just touches. And then it goes down and it touches again. Boop. Now there's a thing on there that'll remind you, make sure you take this off. Yeah, you really want to remember to do that, because if you don't, you try and start your machine, you'll tear up your equipment and potentially ruin the router. Okay, so the z-axis is zeroed now. We're all good with that. See? It says remember to remove alligator clip. Yes, I did. Now we need to zero the XY axis. Now, I actually re-zero the Z and re-zero the XY in between every single bit change, simply because it's just a good idea. It always makes sure that everything is in the right spot. So instead of, I'm just going to do C3. There's little shortcuts in it. Okay. Now give me one sec. I got to make sure that the proper gates are open and everything for our dust collection system. Ranger Steve did an awesome job setting up a cool dust collection system for us. And it pulls it all into that bag right there. I'm going to try and do as much as I can before I have to turn everything on, because then it's going to get loud. But then I'll set it up and leave it for a minute or so you guys can watch it engrave some. But right now I got to make sure that this gate down here is open and all the other gates for the dust collection are shut. Now, another cool thing about this place is because we living in the future, Ranger Steve set us up our dust collection on a remote. So I don't even have to go over there and flip it on manually when I'm ready. Okay. So we're ready to kind of set up our stuff. You can see it says tool is now zeroed for X and Y axis. Okay. Everything's good to go. I double checked my cut files. The three factors are zeroed. We got our Z zeroed, X zeroed, and Y zeroed. So I'm ready to cut my file. So I'm going to do file FP, file part load. And then find, okay, because I have my end mill router bit in there. I do Invention bulb, end mill, cutout. No, sorry. See? Because I have my V-carb bit in there. See? Even I make mistakes sometimes. Because we have our V-carb bit in there, Invention bulb, V-carb bit. So that's one we want to select. Now I can even hit start and still nothing is going to happen yet. Because it might ask me, one, if the proper bit is in there, and two, you have to manually start the router on a button I'll show you before you can actually get it going. Because you definitely want to start that router. If the router stops, or if you don't start the router and you say that you did, it'll drag that bit across and destroy your piece. So always, always read every pop-up menu on this program very, very carefully. So hit start. Is tool number 6 in the spindle? Yes, it is. Tool number 6 happens to be the V-carve bit. Yes, it is. Now, a big thing I want to check also is there's a key here. Now, this key is attached to wrenches, and that's how you actually take the router bits out. And that's interlock, disengage, engage. And so what that is if that's engaged, that means you can actually turn the router on. When that's turned off or you have to use that tool, the router cannot be turned on. So I want to make sure that's on the on position so my router can actually start. Okay. Is ZX zeroed? Why, yes, it is. Okay, now it says start router spindle with start button. What I'll do is I'll turn our vacuum system on first, and then I'll start the router, and then I'll hit OK, and it should start cutting just fine. So I'm going to zoom back out here. Then once I get this going, I'll give you guys a bird's eye view. Now, I haven't shown you, but because we are in this shop and we're using technically it is a power tool, eye protection. Now this thing is pretty loud. It's not deafeningly loud, so I'm not going to put ear protection in, but if I had this running and I was working in here, I would definitely put ear protection on just because it can be really loud. But always, no matter what shop you're working in around here, you definitely want to have eye protection and protect your eyes. Okay. So, like it said, got to start the router, but first, I'm going to turn the vacuum system on. Clicky. And then we press this green button here to start the router. Now I will say this red button here, I'm not going to press that, but at any point if something were going wrong, you can hit that red button. There's one on the other side too, or you can hit any button on the laptop and the machine will stop. But we don't want to hit that because we want the machine to work. All right, I'm going to start the router. And then over here I'll click that I'm ready to go. Okay. Yeah, sorry, that's really loud, but it's really awesome too. So to give that some time to work, I don't know if it'll be done before we stop doing the video tonight, but it gives you a good idea what it can do. And then I'll make sure once I get it painted and everything, I'll post some pictures so you guys can see the finished product. But the other piece we worked on, that we're working on rather, we definitely can see it finish. But of course, because it is so beautiful out, I'm gonna take y'all on a little walk again on the deck, just because it's so nice and pretty. You can see our lovely vultures flying around. Sometimes it's eagles. We do have eagles that nest below the Invention lab. Hello, Mr. Vulture. Alrighty, back into the lab. Turn that off so you guys can hear me. And as you can see, it did our Elven script quite beautifully, actually. So now, I'll show you guys, we can set this up to do the vector cut. Get this all set up, ready to go. Sorry, I clearly did not go to film school. I'm just a simple woodsman and blacksmith. Okay. So now we want to get all this cut out here. So like before, we just go to our print menu, preferences, and instead of raster, we go to vector cutting. Now I want this to cut through. I'm actually probably gonna cut this twice, just to make sure it gets through all the way and gives it a nice burnt edge look. So I'm gonna set the speed. I'm gonna set it about 20 to start. No, yeah, I'll do about 18 to start. Yeah, we'll go to 13. Okay, power all the way up, and I'm actually gonna do frequency all the way up. Frequency is the number of times that the laser fires per inch. And when it's doing detailed cuts, a lot of times that can help. If you set your frequency really low, you can actually make stuff look kind of like a perforation. But I want this to be nice, clean cuts. And so I definitely want to get my frequency up there. Okay. Because this is the same properties menu as before, we got our 24 by 12, but it's always a good idea to check. Again, with any of these machines like this, make sure you have your parameters set correctly. Otherwise, you could very, very, very easily mess up your piece. Okay, I think everything's set, ready to go good. So we're gonna hit OK. Actually, was that set right? Yep, okay. Sorry, I had to double check something. Okay, and we're gonna print, look over at our data thing, wait for the light to turn green. Oh, there it is. All right. Now I don't need to reset the focal length at all because it's the same piece, nothing's moved in there. So there's no reason to reset that. Get this, hopefully where you guys can see this a little better, actually see it cutting. There we go. Alright, so job number 2 is set in there. So really, all I need to do now is turn on the dust collection, or not dust collection, but the ventilation system and the CO2 box, and we are good to go. Now what's interesting about this, it took me a while to figure it out, but you'll notice it's kind of jumping around a little. It actually remembers the order in which you create your lines, and that's the order in which it cuts things in. And so what you're looking at is actually the order in which a few years back I did actually input these lines and draw these lines in. Alright. I think it actually did that just fine in one cut. Sorry about that. Now that's pretty cool. Wow, that turned out great. I'm very, very happy with that. Okay. Set this down. And we'll head back over to the wood shop and see how that's going. One more shot of that. Love the laser engraver. But I'm going to go ahead and turn off that ventilation system so it's not just running for no reason. Okay, onward. And it's nice, the transitions, because then you guys get a nice view of camp too. Now, one thing I didn't mention before when I was showing you guys everything is obviously we do have our Invention lab trailer here as well. That as well has 3D printers in it and a laser engraver and a bunch of other fun stuff for inventing. So we're going to go check this out. It's going to be really loud, so you probably won't be able to hear me. But let's look at the progress on the Invention lab sign. Or Invention Scout sign, rather. Now, one thing to remember, all this equipment is super cool, especially these Facebook Live videos, but that would not be possible if we didn't have internet back here at camp. So we definitely want to give a shout out and thanks to all the people who have made that possible. Jeannie Sinquefield, our friends at Como Connect, Bradley Kearns, who does a ton of work for us here, Cliff McBride, and many, many others who have worked hard for us to have internet back here for our facilities. Not only for these Facebook Live videos, but for searching for programs, updating equipment, and just countless other things that has been helpful for us. So big thank you to everybody who made that possible. Sorry, I'm adjusting the tripod. That's why everything's moving weird. All right. So the Shopbot's going to be quite a while. It hasn't even gotten into the fine detail yet, so I'm not going to leave the camera sit there. You guys don't have to watch all that. But I wanted to thank everybody who joined us this evening. I always enjoy doing these videos. I always enjoy doing projects here. Like I've said before, if you have any questions, please feel free to post them in the comments. And if you have any suggestions, please feel free to post them in comments for videos we can do. I know that I'll be doing the handle on the knife I produced the other week. I want to do that as a video, show you guys how to put, or at least how I put handles on knives, so you guys can see the finished product of that. And there's going to be some more real cool stuff coming out. I know we're having a online camporee coming up, where we're going to be having a bunch of live activities going on. But if there's something you guys would like to see in particular, please let us know. You know, I'm more than happy to accommodate if I can. But thank you again for joining us. I hope everybody's having a good, safe, and fun Friday night. I know I am. It's beautiful out. So I'll leave this sit here. You guys can watch part of the sunset. And while I get some things shut down. So feel free, enjoy the sunset. It's pretty. From Lake of the Ozarks Scout Reservation, Great Rivers Council, you guys have a great night. Thank you. Okay. Good night, everybody. I'll show you the sunset again, so this isn't the last thing you see. Have a good night, guys.